Hi, hi, hi. Good morning, good morning, good morning. Hi, good morning, good morning, good morning. Yeah, good morning, good morning, good morning, good morning, good morning, good morning. Yeah, good morning. Bagunara, Bagunara, Bagunara. Yeah, okay. Very good, very good, very good. What's going on? I'm also good. I'm also good. Yeah. So what's going on? What's going on? Chilling or studying? What's going on? Yeah. Now this question became meaningless. Sir, now what's to talk about studying, sir? Chilling. Yeah. Sorry. Yeah. Okay. After a few days, only chilling, and for coming few days, only studying. Yeah. Means matter of only 2 days, I think. Today is 10th. Huh? Or 9th? Acha, today is 9th. Oh my God. Okay, no problem, no problem. Okay. Yeah, okay. So more time is not left, so I will also not take your more time. One thing I will tell you, one topic I will tell you, not a topic, okay. One concept I will tell you. Yeah, after 2 days, yeah, obviously all of you are going to rock. Your V day is coming. Yeah, V day is coming after 2 days. Yeah, you have to give your best performance and you'll rock in grand test 13th. 12 grand tests will be completed on Saturday. We have holiday and Sunday is the 13th grand test. So 13th grand test you have to rock. Yeah, that's it. Nothing else. Yeah. After that, Manchi life Rawali. Yeah, Manchi life Rawali. Yeah. Okay. No problem. So I know your time is important. So let's talk about the thing which I want to tell you. So be focused. Be focused. Be focused. Be focused. Yeah. Simple thing, not very complicated. Okay. I just want to remind you about this topic because we have not covered up any question from here during our grand test. That is one thing. Okay, no problem. And during our main class also, this thing is not given that much in NCERT. So normally we ignore this concept from NCERT. But actually previously some questions has been asked from here. I told you earlier also, there will be not even a single question in the NEET exam whose concept you will not know. So this was the single question which was left, whose concept was not told by me. Yeah. So that's why I'll be talking about this topic. Is it okay? Shall we start? Shall we start? Yeah, okay, no problem. No problem. Yeah. So be focused, understand how we'll be talking about. Yeah, okay. Yeah. So one thing everyone knows, behavior of capacitor, inductor in AC circuit. You know, whenever AC is applied, capacitor will have XC, XC will be 1 by omega C, inductor will have XL, XL will be omega L. Everyone knows all these things. When resonance will happen, all these things are known to everyone. Is it okay? Is it okay? Bol do something, come on. Yeah, okay, no problem. But we'll be now talking about behavior of capacitor and inductor with DC source. If battery is connected across capacitor, if battery is connected across inductor, then in that situation, how capacitor and inductor will behave. So we are going to talk about, you can write this small topic so that after class revise for 5 minutes, it will be done. You can write name of the topic, behavior of capacitor and inductor in DC circuit. Actually, this is part of DC circuit. So DC circuit is itself a big topic. So in NEET questions are not asked from DC circuit, a special situation is asked. Previously, they have asked you this question. So that's why we're not leaving this concept. Yeah. So we'll be talking about behavior of capacitor and inductor in DC circuit in the battery. If you connect a battery across capacitor, how capacitor will behave. If you connect an inductor across capacitor, how inductor will behave. Yeah. If you connect inductor across battery, how it will behave. Is topic is clear? In AC already knowing. In AC you already knowing. Sir, inductor will have XL. XL will be omega L. You know capacitor will have XC. XC will be 1 by omega C. But this is the things that happen in your AC circuit. Yeah. Now, if it is DC circuit, if a capacitor is connected across battery, then what behavior will be there? If inductor is connected directly across battery, what behavior will be there? So always remember, be focused, being understanding. Very, very important part. Just be focused. Yeah, okay, no problem. Yeah. Always remember, here in this type of situation, connection of capacitor to the battery, connection of inductor to the battery, always they will ask you for two different situations. First, they will ask you T equal to 0. Means just after switching on. Yeah, just after switching on. If you just switch on, then what will happen? Just after switch, you switched on, that is t equal to 0. And second thing they will ask you, t equal to infinity. T equal to infinity means after long time. And this is also known as steady state. This is okay? We are going to talk about behavior of capacitor and inductor at these two different situations. T equal to 0 and t equal to infinity. T equal to 0 means just after you switch on the circuit. That is known as t equal to 0. And t equal to infinity means after long time. Long time means your circuit will reach steady state. So these two situations are asked. Is it okay? Bolo bolo. So two situations we are going to study: behavior of capacitor and inductor at t equal to 0. When you just switch on the circuit, sir, how capacitor will behave, how inductor will behave. And if you talk about long time, after 10 hours, after 20 hours, in the case of steady state, what will be behavior of capacitor and inductor? So always remember, if you talk t equal to infinity, I'm writing here capacitor and inductor. And I'm writing here directly. Yeah, okay, no problem. So always remember, t equal to 0, capacitor behaves as 0 resistance. At t equal to 0, capacitor will behave as 0 resistance and inductor will behave as infinite resistance. You know, both are reverse of each other. You have studied so many times. Their phase difference is 180 degrees. So at t equal to 0, your capacitor behaves as 0 resistance. 0 resistance means short circuit wire. And t equal to 0, your inductor behaves as infinite resistance. Infinite resistance means open wire. And at t equal to infinity, reverse will happen. At t equal to infinity, capacitor will behave as infinite resistance and inductor will behave as 0 resistance. Infinite resistance again means open circuit. Current will not flow through the capacitor. T equal to 0 means your you can say short circuit. Short circuit means simple wire. Is okay? How to remember, I will tell. Don't worry about that. So how to remember this at this point of time, I will tell you how to remember. Is this concept is okay? Always remember, if you connect a capacitor across AC, you know how it will behave. When you connect across if you can, okay, now be focused. Again, I am going to repeat this concept. Bring understanding in your mind. How to remember, I will tell you after this. Yeah. So always remember, AC behavior we know. How capacitor behaves in AC, you know, XC will be there, 1 by omega C, phase difference, current will lead, voltage will lag. You have know all these things for AC circuit. But if someone says you, sir, if you connect a capacitor directly to a battery, if you connect a capacitor directly to a battery, or if you connect an inductor directly to the battery, in that situation, what will happen? So always remember, at t equal to 0, capacitor behaves as 0 resistance. 0 resistance means it will behave as a simple wire. No resistance will be offered. Inductor will be reverse of it. So t equal to 0, capacitor will behave as 0 resistance. Inductor will behave as infinite resistance. Reverse will happen. You have to only remember one. If you remember one, other you can do. At t equal to infinity, reverse will happen. Capacitor will behave as infinite resistance. Inductor will behave as 0 resistance. Done. Bolo. Yeah, now see how to remember it. You'll be saying that in exam you'll get confused. So you can remember like this. I will tell you a very good way to remember. Okay, no problem. Actually, you know, t equal to 0 means how much charge is present on the capacitor. If anyone asks you at t equal, now be focused, important part. If I say at t equal to 0, can you tell me how much charge is present on the capacitor? 0 charge. Yeah. Acha, power gone in the class. Huh? Okay. On the generator. Just wait for 2 minutes. I think power cut happened. Classroom power gone. Classroom power came. They are showing like this. No. How you are getting my voice? Okay, no problem. Sir, power gone. Nice. Yeah, this will be uploaded on YouTube also. No problem. Sir, don't have 2 minutes also. Nice. This is the attitude we want. 2 minutes in NEET means 10 marks. 10 marks means AIMS Delhi or AIMS Mangalagiri. When you became so serious, sir, 2 minutes also not there. 10 days back chilling. Sir, Yeah. Power came in the classroom. They are showing like this. Today is your birthday, Galaxy. Very good. Happy birthday. May God give you very good rank in the NEET exam. Acha came. Who is asking about today is your birthday also, Yashwant? Okay, happy birthday. Come on, this is the motivation people want. Okay, your birthday also, Deepika, happy birthday. Come on, give chocolate online. Yeah. Okay, classroom came, power. Light came there. Yeah, I am also seeing light is there. How they are saying? Sri Gosalites also someone, yeah. Lata, your birthday also, blessings only for, but no, blessings for everyone. Come on. For blessing, we will come separately. For half an hour, we'll have meeting before going to NEET exam. Acha, someone birthday is on 12th September. Very good, lucky person. Yeah, birthday boy, birthday girl, NEET girl. Power came. Shall we start? Classroom. Is it okay? Classroom. Okay, no problem. Their thumbs are very small, even not appearing. Arey, come on, Akhilesh, sir. Arey, come on, be like this. Yes, sir, came. Sir, came. Sir, came. Power came, sir. Yeah, okay, no problem. Now be focused. Now be focused. Yeah, time is less. Okay. 15 to 20 minutes more. Only this thing you need to understand. After that, I will give you 1-2 circuit. It will be completed. So be focused, understand. Yeah, you can leave. Okay. Okay. What you did? Already it's going good. Okay. Yeah, okay. Now, so what I said you, behavior of capacitor and inductor in our DC circuit. T equal to 0 means just after switching on the circuit, capacitor will behave as 0 resistance, inductor will behave as infinite resistance. T equal to infinity, reverse thing will happen. At T equal to infinity, capacitor will behave as infinite resistance, inductor will behave as 0 resistance. If this concept is okay, you can remember like this. Always remember. Just, yeah. Okay, no problem. Be focused. There is only one way I will tell you, you'll be able to remember. No need to revise it. Yeah. Okay. Always remember, you can think capacitor is a device now who is always having hunger for charge. What is capacitor? Capacitor is a device which is used to store charge now, which is used to store electrostatic potential energy now. So always remember, capacitor is a device which has always hunger for charge. You tell me T equal to 0, how much charge is present on the capacitor? How much charge is present on the capacitor? Means it is hungry. You tell me if you give food for capacitor, charge is the food. You tell me if you give food to a hungry person, what he will do? He will take all the food. Like me, Baba, all the food means it will not offer any resistance. Like me, if I'm hungry, I want sweet, I have hunger for sweet. If you give me the sweet, what I will do? Will I say don't give? I will take all the sweet. No resistance I will offer. Yeah, no resistance. So that's why at T equal to 0, capacitor don't provide any resistance. It will behave as it will say, okay, charge, you are coming. Please come, please come, please come. So how much resistance capacitor will offer? 0 resistance. But you tell me after some time, hunger will be completed now. What after some time, what you will do? You are eating, you eat 10 kg of sweet. After that, what you will do? After that, what you will do? When sweet will come, you will say, no, don't come. Why you are coming? I am now satisfied. That is what is happening. T equal to infinity. After a long time, how it will behave? As an infinite resistance. As an infinite resistance. As an infinite resistance. Done. Bolo. Come on. Whenever such question comes, think of me. If you think of me, you'll be able to do. You tell me at T equal to 0, if you give me sweet box, what I will say? Did I oppose that sweet box? No. Means what is my resistance? 0. But if everyone started giving me sweet box, my car is full of sweet box. Now still if you give, what I will say? Don't give. This is very rare. But that possibility is there. Still, I will say give that. Yeah, okay. But yeah, I will say stop. That means if you remember for capacitor, na, inductor will be reverse of that. You tell me at t equal to 0, how much resistance capacitor offers to the circuit? T equal to 0, how much resistance capacitor offers? Zero resistance. Zero resistance means short circuit. A hungry person do not offer any resistance. Yeah, okay, no problem. Yeah. So that means t equal to 0, zero resistance. T equal to infinity, how much capacitor will offer resistance? Sir, satisfied. Hunger completed. Infinite. For inductor, what will happen? For inductor, what will happen? For inductor, what will happen? Reverse will happen. For inductor, reverse will happen. That's it. That's it. Concept done. Concept done. Bolo, bolo, bolo. Come on, do one question. Do one question. Yeah. Okay. Yeah. You write. Find current in the circuit. Find current in the circuit at t equal to, find current in the circuit at t equal to, find current in the circuit at t equal to, first you write t equal to 0, you have to find current, means here I am putting one ammeter, you have to tell me reading of this ammeter. Second, t equal to infinity. I'll give you the values also, no problem. This is 9 volt, this is 2 ohm, this is also 2 ohm, this is also 2 ohm, this is also 2 ohm, this is of 1 Henry, this is of 10 farad. These values doesn't matter, they will ask you simply. Yeah, come on. Find current at t equal to 0 and t equal to infinity. T equal to 0 and t equal to infinity, you have to tell me reading of this ammeter. What you will do whenever such question comes, redraw the circuit. Redraw the, yeah, okay, very good. T equal to 0. T equal to 0 is asked now, you'll remember, sir, at t equal to 0, capacitor behaves as zero resistance. Zero resistance means short circuit. Make it a wire. Make it a wire. And what inductor behaves? Come on, tell me at t equal to 0, how inductor behaves? At t equal to 0, how inductor behaves? Infinite. Infinite means open wire. It will not allow any current to pass. That means if you see this whole circuit became useless now, no current can flow. So can you find R net? Current will come from there only. What is the net resistance? Net resistance. This 2 will give you 1 in parallel. 2 1. 1 and this 2 in series. That is 3. So 9 by 3. That is current will come 3 ampere. Arey Baba, bolo bolo, come on, done. Both situation it will come 3 ampere because I've given you the same value of resistance. In second situation, if t equal to infinity is asked, you have to always redraw the circuit in your neat paper. Redraw the circuit. Now just see what will happen. Now what will happen? Redraw the circuit. So t equal to infinity you want now. T equal to infinity you want now. What will happen at t equal to infinity, sir? T equal to infinity. What will happen to capacitor? Come on, tell me. What will happen to capacitor? T equal to infinity, its hunger got satisfied. It will not allow any current to pass. So what will happen? It will behave as open wire. And inductor will behave as a short circuit wire. So now here no current will go. This is the circuit. Again, if you find 2 in parallel will give you 1. 1 and 2 in series will give you 3. So 9 by 3, this will give you 3 ampere. Done. Final question. Come on. Do one more question. Do one more question. Do one more question. Yeah. Do one more question. This 2 ohm. Let's give as this as 6 ohm. Let's give this as 4 ohm. This is the ammeter. You have to tell me t equal to 0. What is the reading? T equal to infinity. What is the reading? Battery. Acha, battery. Oh my God. 12 volt. Battery 12 volt. Not required. Value is not required. This is value is not required. Whatever the value given, they will behave either zero resistance or infinite resistance. Battery is there in a DC circuit. T equal to 0. Yeah, correct. 2 ampere will come. T equal to 0 means what? T equal to 0. This is very easy. Student feel this is a very tough. T equal to 0 means, sir, capacitor is completely hungry. It will not offer any resistance to the current. So all current will go through the capacitor. It will offer us zero resistance. Zero resistance means short circuit wire. Inductor will offer reverse of that, infinite resistance. Infinite resistance means open circuit. Now, what is the next circuit? You can see. No current will go here. So what is the current? Current will come total EMF upon total resistance. That you can say 6. So 2 ampere. Now you tell me at T equal to infinity, what will happen? T equal to infinity, what will happen? T equal to infinity. T equal to infinity. T equal to infinity, what will happen? Now this will behave as open wire. And now this will behave as a closed wire. So you can see, circuit will be like this. No current will go in this. So what is your current? Current will be coming as 12 upon 8. That is 3 by 2. Are kuch samajh mein aaya? Bolo, bolo, bolo. Come on. Done. I think everyone got the idea. Everyone is giving reply so fastly. I think you have got the idea. So come on, T equal to 0, how capacitor behaves? T equal to 0, how capacitor behaves? T equal to 0, how capacitor behaves? 0 is hungry person. Remember the hungry person like me. Yeah, T equal to 0. If you know one, other will come. T equal to 0, 0 resistance. T equal to infinity, infinite resistance. For inductor, it will be reversed. Done. Yeah, okay, no problem. Now, sometimes they can also ask you charge on this capacitor. For example, just see here. Yeah, okay, no problem. This is just one level beyond. Okay, but you can do. They will also ask you, what I said you, T equal to infinity, no current was flowing through it now. But still potential difference will be there due to this. Yeah. So you can find potential difference across this capacitor and you can find energy stored in the capacitor, that is half CV. I will give you one question. Come on, do fast. Find the energy stored. Exemplar question I am giving you. Find the energy stored in the capacitor in steady state. Find the energy stored in the capacitor in steady state. Find the energy stored in the capacitor in the steady state. Okay. You will simply say, sir, what's so big deal? In the steady state means our circuit is like this now. In the steady state means this is like open wire. No current will flow here. So this is our circuit, sir. So first we'll find the current. Better to take this value as 2. Better to take this value as 2. Yeah. Okay, no problem. Yeah. Take it as 2 ohm. Yeah. So what will happen? Current will flow like this. There will be no current here, but you can find how much current will come. Come on, tell me how much current will come. 5 upon total resistance 2.5. So current will come 2 ampere. That means 2 ampere of current is flowing. 2 ampere of current is flowing. That means what is the potential difference across this? Potential difference V will come. I into R, 2 into 2. That means this potential difference will come 4. If potential difference is 4, you can find same potential difference now you can see in parallel. So how much energy will come? Half C into V square. 4 square, that is your 16. So answer will come 8 joule. Bolo, come on. Got the idea? Are bolo. Did you understand how to find energy stored in the capacitor? This is also asked. Yeah, last question from here. Steady state means current constant. Don't ask the same question. Yeah, okay, last question. Come on, do. This is 6 volt. This is I'm giving 1.5. This I'm giving this is also 1.5 ohm, 1.5 ohm. Capacitance is 2 farad. This resistance is also 1.5 ohm. This is of 2 Henry. Tell me the energy in capacitor. Energy is stored at T equal to infinity. If nothing is given, then also means steady state only. Because this is the final circuit that we have, steady state. If nothing is given, you will always take a steady state. Come on, tell me the energy in the capacitor. First, find the current. Yeah, I think 9 is coming. Yeah, now everyone is giving the correct answer. Yeah, very simple. It's very simple. You simply say, sir, what you are asking, nothing is given means steady state. Now, steady state means, sir, at t equal to infinity, capacitor behaves as infinite resistance. That means here no current will go. This is all like open circuit, sir. Open circuit here. Yeah, and this will be like closed circuit. Inductor will behave as zero resistance. So what is our circuit? First, decide the current. So this is the current that will flow. That is 6 upon total resistance 1.5 plus 1.5. That is 3. So current is 2 ampere. So 2 ampere is coming like this. 2 ampere, that means here potential drop V will be coming as 1.5 into 2. That will be coming as 3 volt. If this is 3 volt, it is connected in parallel. Here no current is there now, so no drop is here. So whatever the voltage you have V, that will come here. And this will give you energy half C into V square, 3 square. That will be coming as 9 joule. Done, done, done. Bolo, bolo, bolo. Final, everyone understood? Can I be 100% sure if such question will come in NEET exam, will be able to do? I both 100% surety. You write one more question. Come on, do one more question. You write. You write. You write the question. Good question. This question can be also asked. Somewhere I have seen this type of question. That's why I'm telling you at the last point. Yeah. Yesterday when I slept, these questions came in my dream. I opened the NEET paper. You know, you only don't get the dream of exam. I am also getting dream of exam. So when I was there as an invigilator in that exam. When I opened, such questions were there. So that's why I'm leaking out the paper. Yeah. Okay, come on, do the question. You write. You write, in an LCR circuit, frequency is found to be. In an LCR circuit, frequency, resonance frequency is F naught equal to 1 by 2 pi root LC. You're not able to sleep, that's why you're not getting dream. Okay, maybe you are there, but I sleep and I'm getting dream. And in dream this question appear. Yeah, In an LCR circuit, resonance frequency is F naught equal to 1 by 2 pi root LC. If frequency of the source, is less than resonant frequency, if frequency of the source is less than resonant frequency, behavior of the circuit will be, if frequency of the source is less than resonant frequency, behavior of source will be RC circuit, RL circuit, LC circuit. Fourth, can't predict. Come on. First or second? First or second? RC or RL? Or they can ask you current will lead or lag. That can be also related. If frequency is less than resonant frequency. Okay, correct answer is half correct, half wrong. Correct answer is the first option. First option is the correct. Always remember, be focused, be focused, be focused. Understand, we have not given any question like this previously in the test. So that's why I'm covering up this type of question. And I want everyone, if such question comes, you must be able to do. First thing, always remember, at resonance, what is the behavior of, in main class I told you, yeah. At resonance, what is the behavior of LCR circuit? Can you tell me at resonance how LCR circuit behave? Purely resistive. Purely resistive means current and voltage both will be in the same phase. Maximum power will be there. But if someone says, sir, my frequency is less than resonance, then what will happen? If my frequency is more than resonance, then what will happen? Always remember, if your frequency is less than resonant frequency, behavior will come RC circuit. And if your frequency is more than resonant frequency, your behavior will come RL circuit. RC circuit means I leads. And here what will happen? V leads. First you write this, come on, very fast. Then I will tell you how to think. It's very easy to think. You tell me if frequency is less. Okay, no problem. 5 more minutes we will have. Okay, yeah, okay. You tell me, yeah. Okay. If frequency is less, who will dominate? XL will dominate or XC will dominate? You know, XL and XC both are opposite. XC dominates, because you know XC is actually 1 by omega C now. So if frequency is less now, omega is less. If omega is less, XC will be more. Are at the time of resonance, XC and XL both balance. I'm not talking here, talking before it. If your frequency is less than resonance, who will be more? XC will be more or XL will be more? XC will be more. If XC is more, XC will cancel XL and remaining, that's why behavior will be your RC circuit. Are bolo, come on. Are you getting the idea? You cannot bug up it. So that's why I'm bringing understanding also. You tell me frequency is more than resonant frequency. At resonant frequency, both are equal. But someone says, sir, my frequency is more than resonant frequency. Means who will be more? XL will be more or XC will be more? XL is directly proportional to omega na. XL equal to omega L. If your frequency is more than resonant frequency, XL will increase and XC will decrease. So XL will start dominating, and once XL dominates, it cancels C. So behavior will become RC circuit. Done. Can I ask you this thing? Come on. At resonance, what is the behavior of LCR circuit? At resonance, what is the behavior of LCR circuit? Purely resistive. You tell me frequency is less than resonant frequency. What is the behavior? RC. Frequency less, na XC will dominate. If XC will dominate, yeah, okay, no problem. Next. Achha, tell me, if frequency is more than resonant frequency, who will dominate? XL will dominate, because XL is directly proportional to omega L. XC is inversely. If you decrease the frequency, na XC increases, XL decreases. Are you getting the idea? Bolo, classroom done. Yeah, okay, no problem. Last question, come on. Last question, you right? Okay, no problem. I'm going to give you two circuits. Now AC, I'm not talking about DC. You tell me, yeah. Right. If obviously one resistance is there, you can take one resistance, no problem. You write, if a ferromagnetic material is, and here one bulb is there. If a ferromagnetic material is inserted in the core, you have to tell me brightness of the bulb, whether brightness will increase or decrease. Brightness of the bulb. Here also bulb. And here I am going to put a dielectric between the plates. In which situation increase, in which situation? This situation 1, this situation 2. In which situation increase or decrease? This was asked last year in the NEET. COVID NEET, this question was asked. And this has been also asked 10 years back. This question has been asked. Good question. Yeah. In first case, increase or decrease? Just be focused, I will tell you, time is not there. Just bring understanding how to think in the NEET exam. Chalo, take care. Be focused. Always remember, once you put L inside na, once you put ferromagnetic material inside na, what will happen? Due to ferromagnetic material in the core na, more magnetic field, more flux, your self-inductance, L increases. Is it okay? L increases. If you put a ferromagnetic material, our mu value will increase na, permeability will increase na. If you remember, self-inductance was directly proportional to permeability. So once you put the ferromagnetic material, L increases. If L increases, XL also increases, because XL is omega L. If XL increases na, Z increases. If Z increases na, current decreases. V by Z. If current decreases, what will happen to the brightness? Decreases. Bolo, come on. Got the idea how to think? No, don't remember. Yeah, I told this thing. Yeah. And this question I gave you mainly for this question, because this has been asked last year, so they will not ask you this they can ask. Come on, tell me here what will happen. Tell me the process. Once you put the dielectric now, what will happen? Who will first change? Capacitance will change. Sir, capacitance will increase. Once capacitance will increase now, XC will decrease, or XC equal to 1 by omega C. Once you put the dielectric, capacitance increases, XC decreases, means Z decreases, means current will increase. So here brightness increases. Are you getting the idea? Bolo. Got. Yeah, you have to get the idea. Yeah, okay. Actually, someone says you, if plate separation is half, if you halve the plate separation, what will happen to the brightness? If you halve the plate separation, what will happen to the brightness? If you halve now, think, once you halve, if you decrease the plate separation now, capacitance will increase. Or C equal to epsilon naught A by D. If you decrease the plate separation, capacitance will increase. If capacitance will increase, XC will decrease. If XC will decrease, Z will decrease, current will increase. Will you be able to relate all these things? Yeah, okay, last thing, one more minute. Yeah, okay, brightness will increase. Yeah, okay, no problem. Last, yeah, okay, no problem. You tell me, one thing is asked. Who allows DC to pass? Who allows AC to pass? Two devices are there now. Come on. One thing I will tell you, just, yeah, okay, always remember, always be focused, yeah, Always remember, capacitor is a device, capacitor block DC and allow AC. And if you talk about inductor now, inductor, yeah, use this concept only when such question is asked. If you talk about inductor block AC and it allows DC to pass. Reverse, you always know both will be reversed. So always remember, so if anyone thinks how to remember, you can remember like this. For example, if DC is there now, if DC means a straight current now, DC means current in the same direction, now what will happen? If DC is coming like this, a way to remember. If DC is coming like this, what will happen? Here plates are there now, what plates will do? They will reflect it back. That's why this is just a way to remember. But AC can pass easily now. You can see. Are Baba, if wall, are you getting the idea? This is the way to remember. Capacitor block DC. Capacitor will block DC. You can think, okay, sir, DC means a straight current, sir. Current is coming like this. What will happen? Current is coming like this. These plates will reflect it back, so current will not be able to pass. So blocking of DC is done by capacitor. But if anyone asks you, sir, what capacitor will allow? If it blocks DC, it will allow AC. If it will allow AC, how AC can pass? You can see. AC is stylish people can adjust anywhere. Are Baba, straightforward people cannot adjust everywhere. Stylish people can adjust anywhere. And when you go in trade, you can adjust anywhere now. Yeah, you are stylish people, come on. Yeah, now here see. For inductor allow AC to pass because here gap is there, in between gap is there. So AC can easily go between the gaps. But DC like this, it will get trembled in the coils. Are you getting the idea? Bolo. Hey Bhagwan. Yeah. Are Baba, turns are there now. So what will happen? Reverse you can remember. Come on. Yeah, okay, no problem. I will give you last question from here. You write. This current is AC plus DC we are having. You have to tell me what will be present across capacitor, what we will obtain across capacitor, and what will obtain across inductor. Yeah, this will allow AC to pass. Yeah, okay, no problem. So always remember, if it allows AC now, it block DC. Whatever it will block, it will come across it. Here DC will come and across this AC will come. Are you getting the idea? If you block something, that will be present. Are Baba, if 100 food items are coming, the food item which you will block, that will be present for you now. Other will go now. So that is, if it blocks DC, DC will come across it. And if it blocks AC, AC will come across it. Done. Final. Full and final. Yeah, so these are the things that we have. Achha, one more thing I will tell you. Last. Is it okay? 2 more minutes. Not understood, good. If you don't understood, that's better. Yeah, okay, Previously you not studied anything, so you cannot understand. Leave it. Yeah, okay, no problem. Yeah, okay. Achha, one more thing is there. Understand, this question is given in NCERT, that's why, Okay. Now this question is given in NCERT. That's why I'm talking about this question. I'm talking about this question because it is given in NCERT. Be focused. Be focused. Yeah. Actually, tell me, do you know work done in rotating a bar magnet from θ1 to θ2? Do you know the work done in rotating a bar magnet from θ1 to θ2? How much is the work done? What is the formula? You simply say, sir, MB cos θ1 minus cos θ2. Is it okay? Is it okay? MB cos θ1 minus cos θ. Now understand. Yeah. Always remember, be focused. Yeah. Always remember, if your bar magnet is rotated perpendicular to, always remember, if your axis of rotation is perpendicular to plane of the bar magnet now, if axis of rotation is perpendicular to plane of bar magnet, understand what I'm trying to tell. And magnetic field is also, I will give you one question, the question which is given in exemplar, I'm talking about that question only, I will send you that question. Be focused, yeah. This is normally what we use for finding work done, MB cos θ1 minus cos θ2. But in the NEET exam, if question is like that, it is found bar magnet is rotated about an axis perpendicular to its plane. Magnetic field is also perpendicular to the plane. In that situation, always remember, work done will come 0. Because their angle will not. Understand what I'm trying to tell? Be focused. Last time I'll be telling. Be focused. Yeah. Bring understanding. You know now work done will come MB cos θ1 minus cos θ2. Is it okay? This formula okay? Now always remember, if coil is rotated perpendicular to the plane, always remember, if in the question it is given coil is rotated perpendicular to plane about an axis perpendicular to the plane, always remember in this situation your work will come 0. I was telling in the class also. If coil is rotated about an axis perpendicular to the plane, always remember it, because in that situation your M direction will not change now. What is M? M is also perpendicular to the plane. Axis is all. You see, does angle is changing? Does your direction of M vector will change? Come on, tell me. If this board is there, you tell me if I rotate the board like this, does M vector will change? M vector is always outward perpendicular. Now, if I rotate this, you look at my hand. This is the M vector. If I rotate this board perpendicular to the plane, tell me, does direction of M vector will change? Bolo, come on. So if direction will not change, as theta will, if I rotate like this, then angle will change. Look at here. M vector perpendicular to the plane. Axis perpendicular to the plane. I am rotating this. Does direction of M vector is changing? So does angle will change? So if angle will not change, does there will be any work done? No, but if you rotate like this, so always remember, don't get confused in the NEET exam. If they say axis is perpendicular to the plane, how much work is done? 0. Done. I point D. I will send you the question of exemplar. Do that question. I have selected some questions from exemplar which can come directly in the NEET exam. I will send you after some time. When you get the time, you can do. Yeah. So this is how we have talked about more situation. We'll talk. Bye. Study well. All the best. Bye. Tata.